Well, I think it's time for us to get started. 10:35 Pacific, where it's sunny and a little on the cool side today. My name's Mark, your virtual Elmer today, and today we're going to discuss going over building your first kit. Starting from the absolute beginning, we're going to cover safety, what tools are needed, go over the different types of solders involved, how to solder, how to take care of your soldering iron, how to fix your mistakes, because those will happen. Let's see, what else we got here. Then we'll tear into the kit itself, go over what the components are, what they look like, their schematics, what the schematic representation looks like. Let's see. Taking project notes, that's important as you go along. And you work on more projects, sometimes you'll have to make changes or fix something that you've built years ago and you're not going to remember how you did it. Go through, actually build the amplifier, testing. We'll test it real quick. And go from there. So my name is Mark, KA6WKE, and good morning, good afternoon, appropriate salutations for your time zone. Let's see. So we'll get started with safety. We all have hopefully have a certain level of common sense about hot things and sharp tools and liquids and so forth that are poisonous. So hopefully we all have the understanding that we don't drink, we don't eat at your workbench. When you are done working on your kits and things, that you always go wash your hands. I use lead solder in all of my projects. Your country might be different, of course, but in any case, there's still chemicals involved, either cleaning chemicals like alcohol or acetone, or what am I trying to say here? Fluxes and things. And those are best to keep out of the digestive tract. The other thing is, for your environment alone, is some kind of decent ventilation, if possible. I have poor ventilation in my workspace, but sometimes I'll have a fan going to help keep things out of my way. Let's see. So everyone has probably seen this photo on the internet. It's been across many of the amateur radio and electronics sites. And actually, this was apparently a real photo. I found the original from Shutterstock, and showing the young lady holding the business end of a soldering iron. So that's probably pretty obvious. That end is on my soldering station is set for 850 degrees Fahrenheit. I don't know what you Celsius folks use. I think that's around 350 maybe. I don't remember, but that's definitely a common sense thing. You'll notice right away. In my hobby, I have accidentally, yes, grabbed it. Not sure why. Or had it fall in a lap because I left the cord hanging over my bench, over the edge, and a knee caught it, or an elbow or something. So there are some other safety issues here. Of course, the cord hanging off, I understand, is just for the photography purposes. But another safety issue, there's two in this particular photo that are still there, if you can see them. The first one is, in some cases, working on surface mount components and things of this nature on a motherboard, you're going to have some kind of electrostatic strap grounded to what's called an electrostatic ESD safe, electrostatic discharge safe workbench. Now, living out here in California, that's something I have to be concerned with because we can get very low humidity and lots of shocks and zaps and things. And there's been times I've wanted to work on a project and I can't. It's just too. I don't want to destroy something, even though I have an ESD safe work area. I just don't risk it. Wait another day. Folks that live in a more humid environment won't have that so much of an issue, but it's just something to be aware of. The second thing is she has a wedding band on or some kind of ring. Not having anything on your hands, no rings, no other jewelry, a watch, is a very important safety feature because although today going through a low voltage kit and doing some soldering things, it doesn't matter so much. But I want you to get into the habit of not having any metal on your hands because as you learn to build kits and they become more complex and things, and you'll start repairing equipment and you have to have it powered up in order to do the repair. You don't want to accidentally have a metal watch band touch something or a ring on your finger touch part of the circuit board, and now whatever you were originally repairing now maybe became impossible to repair or introduces more problems. So it's best not to wear any type of jewelry. So some of the tools, of course, are soldering station. I have a Weller WE51, WESD 51 iron I've had for probably 20 years. And I like to invest in good equipment. I really enjoy this hobby, so I didn't want to start off with soldering stations and some of the tools of high quality. I wanted to stay that way because you buy them once and they essentially last a lifetime. Let's see what other tools we got on my bench here. For this project, we won't need that one. We'll need this. Need to get a nice set of side cutters. I don't know why my... Oh, that's why my camera is not focusing well, because it's set to automatic. All right. So I have a set of side cutters that I use for trimming leads and things off a circuit board. Like this. Nice and flush on the circuit board itself. Okay. There are other side cutters that are available. For example, this style that we're all familiar with, the regular diagonal cutters. The problem is, they can get sort of flush on the board, but when they cut something, let's see, when they cut something, they can mush the end out like this. And the reason why you don't want it to mush is because when you try and remove the component from the circuit board, you can, hold on, I'm going to change my screen around a little bit. Okay. See, I bumped the box a little bit. Yeah, I'm going to stay with this one. I don't have to keep flipping around. So when you're trying to remove a component, it's quite possible that you can pull the through-hole plating out of it. Now, these are double-sided boards. These are the practice boards we'll use in a little bit. Not such a big deal. But if you're working on a multi-layer board, hold on one second. If you're working on a multi-layer board and pull out the through plating, it's pretty much gone. A pair of nice, smooth, the surface is smooth, needle nose pliers. So you can simply make, basic bends and things like this, nicely. Now, some needle nose pliers are serrated. You see those edges in here. The problem I have with that is if you go to actually use it and make a bend, you'll see that it damaged the wire. Actually, it left teeth marks in it, and that can make the integrity of the lead less strong than it is originally when it hasn't been treated this way. So I always use the small pliers, needle nose pliers that have smooth jaws. Okay, I can throw that piece away. Wire strippers. Get yourself a nice pair called T-strippers or whatever. This particular brand or version that I have goes from 22 gauge wire to 30, which is pretty small for some of the projects. I have another one right in front of me that I can't find. That goes from 16 to 26. I use this more commonly than the yellow one. So the reason why you want to invest in a good wire strippers is if you try to use diagonal cutters and things, you invariably will, trying to strip the insulation off, you will nick the wire underneath it, again making it weak. So when you bend it, it could break. And if your leads on your components have to be short, you may have just ruined a component and you won't be able to use it. Okay, so that's what I use. I also have a little poker, repurposed dental tool I've had for I don't know how long. You can find them at swap meets for a couple of bucks. They're great to have. Solder doesn't stick to them. They're strong, as you well know from the dentist. Let's see, what else do I got? That's about it for different types of tools. Of course, I have the other stuff that are not necessarily that are used. I use a lot our X-Acto knife. I keep that handy. Usual screwdrivers, nut drivers, fine, smaller tip Phillips and things like that. We won't be needing that for this project. So I won't go over all of it. I even keep a set of, when I'm working on really fine electronics, I keep a set of jeweler's tools, real tiny, great for surface mount work. And I am planning on a episode on how to solder and build surface mount kits. Surface mount, excuse me, really isn't anything to be afraid of. It just takes different techniques, different solders to work, and different solders to work with. So the other cool little tool that I've had forever, and I cannot tell you where I got it from, is a caliper style wire bender. So when you're putting in leads on a board, you can put this in the holes and actually then put the part in here and you have perfect bend so the part drops right through the holes without guessing on anything. So I like that. I like that a lot. Let me see. Oh, I forgot to announce that during the live stream I will have chat going. Okay. Yeah, I have chat going. So if you want to ask questions, feel free. I'll just respond via the FT8 mode. No, just kidding. I'll just answer on the screen with voice. I can't type and talk at the same time. It gets messy. So we covered the types of tools that are needed for most small kits. The next thing is solders. And I do pronounce the D, solders. And there's a myriad types of solders in different forms. So we'll discuss the most common ones used in kit building. So the most common one is a standard 60-40 lead type solder. I use lead solder all the time. I can't. I've tried different solders, lead-free solders and things, and they just don't. As a manual process, they don't solder as well. When you're purchasing solder, buy quality solder. There's plenty of stuff available on the various websites for sale that you don't know where it came from. You really don't know what it's composed of. So I typically stick with MG or my other one I like. The gold standard's Kester. They've been around since I don't know, dirt was new probably. And I buy them by the pound. It's just not worthwhile, or half pound. It's not worthwhile to buy a little tube of it because you'll just go through it too fast and it ends up being more costly. Let's see here. So I use two different sizes I keep on hand. One is fairly large. It's 0.062 diameter, 16 gauge solder, rosin core solder. Okay. So let's go over some of these here. So RA flux means oh gosh, now I'm drawing a blank. The A stands for active. Hold on. I'm blocking on the term. Maybe I'll come back to it. Diameter, 0.062. This is very common. This type of solder, the size of this solder is I've used for soldering on bigger components, working in power supplies and things where you have to be liberal with your solder on the board. PL259 connectors. I don't know if people still, everyone crimps these days or whatever. Let's see. It contains 2.2% flux of RA flux. Boy, why am I drawing a blank on the flux? Hold on, this is going to bug me. Let me, something active, really active or mildly reactive? Hold on. Rosin activated. Okay. So this is a rosin activated solder. It means is inside. See if I can look at it in the scope here. Get it down low enough. Inside the solder you can see a little hole. It's a little fuzzy. But inside that hole, there you go, is flux. So when you solder, when you start heating up your joint, the flux becomes liquid faster than the solder. A little bit of it pours out on the board. Solder melts and gives you a nice clean joint. So what the flux does is it stops oxidation from occurring because of the high heat of your soldering iron and the oxygen around it and the metals and so forth. So so this is rosin active flux, which means it's the fastest activating rosin there is. So let me double check my notes here. So this is rosin activated. It is the most active version. This solder is 60-40, meaning 60% tin, 60% or 40% lead. Tin lead is also called tin lead solder. Now the Kester brand I have, you'll see here, is 63-37. Typically that's how it's said, as you don't say tin 63, lead 73. You usually just say it's 63-37 solder. Why there's differences, I really have no idea. I've been soldering for the better part of 35 years, and I cannot tell the difference in performance between the two, 60-40 or 63-37. They all solder the same way, as by feel. So this particular solder is 0.025, much tinier, as we can compare sizes. I use this mostly for the finer electronics that I need to work on. Sometimes some surface mount I've used it for. And it looks, this project could probably use this one, use this solder. And we probably will do that. It also has rosin in it. Let's see if we can get the hole on that one. It's almost impossible to see. But there is rosin inside here as well. And it's not labeled as to what kind. So the other kind is, so we saw RA on this one, rosin activated. Then there's another version or flavor of rosin core, and that's called rosin mildly activated. So it'll say RMA on it. Maybe it did at one time on the bottom of this label. And that doesn't react as fast or as harsh on the circuit board and the components and things like that. Let's see here. So there's another type of solder that I rarely use, but I keep on hand just in case. Silver bearing solder, 0.015. It's even smaller than this one. Now I have no idea how they get. I don't think there's even any rosin in this thing. I don't use it that often, but you're wondering, well, when do you use it? There are certain components that I've used this with that have gold plating on them, or are ceramics. They have ceramic parts. I've used this type of solder on there. It seems to solder a lot easier. The problem with this solder is that it does not contain any flux, and it's a lot. You can tell it's much smaller. We'll look under the scope here. You can see it's even smaller than my smallest solder I typically use. So in that case, when you have a solder that does not have any rosin in it, you have to supply it. And there are several types of, I'm trying to, it's on the floor. There are several types of fluxes available. Actually, there's a lot of different types, but I keep 2 forms on hand. Again, buy a quality brand name flux. Don't buy something off the various websites because that come in plain bottles and you don't know what it's made of. That can be a huge health problem if you don't know the components that are made of. So this particular brand, Deoxit, I like, and I haven't opened it in a while. Here we go. So this particular brand is a paste. And what are fluxes made from? Pine tree sap, mostly, and some other chemicals thrown in. So it smells like, there's like a turpentine smell to it. I use this when I use this on boards where all the, like if I'm doing a repair, say, and I can't just add more solder to the joint because there's just not enough room. Of course, I could clear it off and reapply fresh, but what I do is take a little dab, put it on the joint, and then solder it back down using the original solder. So that's one approach for this. This paste is good because it doesn't run all over the board. It stays put. You may have a reason for that, and on occasion I've had this. On some projects and things, I want it to stay put. And this is it was probably on the packaging then, what type of solder this was. If it was a rosin activated or mildly activated, I don't know. The other one I use is Kester 186. Okay, this is a liquid, as you can tell on the thing. I use a lot of it on surface mount projects, repairs, and things like that where, you know, I don't care so much if it runs around a little bit. And it's really very liquidy. As you can see, it just dab, out it goes. It works really well. And it's like $8 for this bottle, and this bottle will probably last you half your lifetime. So that's good to have on hand. Fuzz. Okay, there we go. Okay, so we've done the different solders, we've done the different types of fluxes. Again, there are other fluxes for other applications out there, but for the person working at home, just enjoying the hobby and building kits by hand, things like this. This is the type of solder, types of fluxes you should keep on hand, and that'll cover 99% everything you need to do. Let's see, there's another type of flux which I don't have. It's called water soluble flux, which means it can be washed off with water. So now I don't use water soluble flux because you still have to clean it off. Some fluxes they say you can leave behind. I don't think that's a good idea either, but I know water-soluble flux, after a while, can actually eat into your project. I don't know why. I've not experienced it personally. It's just what I've read when I was researching fluxes for this episode. So if you use water-based fluxes, be sure to clean off your boards when you're done with them. And it's probably a good habit to also clean everything off with regular fluxes as well. So that brings us into cleaning fluids. the different kinds of cleaning fluids. So there are typically two that are used. One's alcohol and the other is acetone. I only use acetone as an absolute last resort because acetone will dissolve just about anything. It'll leave your board squeaky clean, but if you're not careful and get it on the printed side, the silkscreen side of the board, it'll wipe all that off in a heartbeat. And I'm speaking from experience here. I had a project I was building, and I cleaned off the board in the sink, and we'll go over that here when we start building the kit. And my last pass was to wipe it off with a rag of acetone, and not paying attention, that wiped off all the silkscreen on the board. So that made the project a lot more challenging. Had to have a lot of pages printed out with board component locations on the board. It wasn't easily, but it was figured out. What I do like to use is this isopropyl alcohol 100%. Okay, don't buy the stuff from the pharmacy or the grocery store. I think I bought a gallon of this, 4 1-quart containers for $20 on Amazon. The reason is what makes 99% alcohol or 97% alcohol is that they mix it with water. And you don't want to put water on your boards when you're cleaning them. And it will, 99% will clean your board. But after it evaporates, you'll notice it leaves this white powdery sheen behind, and that's the water. So you don't want that on your board. Buy pure 100%. You don't have to worry about it dissolving your silk screen on the other side either. And it's a lot easier on your hands. If you're like me, I don't typically wear gloves or anything, and which is probably a bad habit I should start thinking about doing. So use pure 100% alcohol. I put it in a smaller container, so when I use it, I don't have to carry around the whole quart thing. Okay, so that covers the first 4 subjects here. Safety, what tools are needed, different types of solders, what they are, what are the different types of solder fluxes that are used, some ideas when to use them. Oh, I left out one other solder I forgot. Solder paste. So when I'm working on surface mounted parts, I use solder paste in a syringe. Now this is pretty old. It's separated. You can see, I don't know if you can see it in there. Let's look in the microscope. It's kind of separate. You see the gaps in there and that. So this is solder with flux already mixed in. It's a paste. I don't know if I can get any out. Just a little bit. Let's look under the microscope. So it comes out as a paste. Okay. Now this is bad. This stuff I'm going to recycle. Not recycle, but throw away in the, not in the trash. It has to go, I keep a bin of stuff that I can take to my local waste management and drop off when it's chemicals and things like that. So you see it's all kind of not real, it's all glumpy and things like that. So this isn't good anymore. Typically you store it in the fridge, but this is what I use for my surface mount projects when I'm working on them. Just take it out and say this is a pad. You just squirt some down on the pad. You can put the part down, hold it with a tool, and hit it with either a soldering gun, soldering station, or I have a hot air station as well. And I will, like I said in the early start of the episode, I will be doing one for surface mount. Some techniques on how to solder surface mount components, how to remove them, how to hopefully get your hands, if your hands, how to help your hands so they don't shake so much, and so forth. I haven't really put all that together just yet, but we will. So the next thing is how to solder. How are we going to solder? Well, we're going to learn. Now, soldering is very much done by feel. Okay? So we'll talk about some of the techniques and kind of what it feels like. Your best thing to do is, if you bought the boards I recommended prior to the episode, get some practice board. Get some little pieces of wire. These are just leads I cut off from another project. I keep some of these around. They make good jumpers and things. But we'll practice with these leads and doing the soldering. Let's talk about soldering examples. Now, Adafruit published this. I was looking for something when I was putting this episode together. And I apologize for going off the charter of this live stream where there's no preparation. We just start building, and I make comments as I go along. So there's no preparation, there's no post editing, things like that. But for this episode, I prepared for to make sure I covered everything. So I wanted a graphic on the steps to soldering. And it was like, I can't draw something like this. But it popped up on the 100 Watts in a Wire Facebook page the day after I was thinking about it. I'm like, oh, thanks, Adafruit. I'm going to use this. So props to them for putting this graphic together. And it shows you the steps. And this is one style of soldering a component down. There are different techniques in holding your iron in things to help with heat transfer and doing the actual soldering. The bottom row shows all the different bad solder joints and a mistake on a short, and we'll go over that as well, how to fix shorts and other things as part of this episode. Hopefully I can create a cold solder joint. Definitely I can create one with too much heat. That's pretty easy to do. Too much solder, pretty easy to do. Not enough, same. Short, same. So the cold one might be difficult for me, but we will give it a try. All right, still drinking coffee here. Okay, let's get these out of the way. So my soldering station, like I said, is a Weller. It's a Weller WESD 51 station. I think they're about $130. And let me see if this will autofocus now. Okay, good. And I've had it for like 20 years. So in the grand scheme of things, buying the higher quality components, tools and things is well worth it. Especially if this is a hobby you really like, and there's just no reason not to invest in good tools. So we'll go over the different types of tips. This is a standard chisel tip, and of course my camera doesn't want to autofocus. What's up with you today, camera? It's a standard chisel tip. Get it closer. I don't want to get it too close to the camera so it doesn't melt anything. And it looks like a screwdriver end on it, actually. Okay, and we will use this shape. This is the most common shape that I recommend people get, and the most common size. It's a 1/8 inch, I think, to use. And you'll notice on the that's better. You'll notice on the tip where it's starting from the left, it's a dull gray, and then all of a sudden it gets kind of shiny. You can see the oxidation happening as the iron stays out in free air. So what you do first is you have to tin a tip. Okay? Do it when, you know, most tips these days when you buy them, they come pre-tinned. But I still like to clean them off and let this get hot a little while here. So we need to tin it. And we do that. We tin the soldering iron tip. I start with some tip cleaner. One of these brass shaved brass Brillo pads. Okay, and of course rosin, and then solder. So here we go. We're going to tin this tip. So you start off with getting everything open. Okay. So we'll see. Look under a microscope. It's kind of, it's all right. I could keep working. You can see on the one side there, it's getting kind of beat up. So I like to start with sticking it in the tin cleaner, and you can see that it applied what looks like a little bit of solder on it, which it did. There a few times, and then stick it in here. So now you can see the tip is much better. It's cleaner, shiny, okay? A little bit of flux in there. Now you see I talk about the ventilation. A little more flux, we'll hit it again. Let it sit on there. Clean it off. And there we go. A nice, clean tip. All tinned, all ready to go. So don't let tinning your tip seem really difficult. And you should do it, well, if you take care of your tip, you don't have to do it all that frequently. So what I just did now was put solder on the end of the tip, because I'm going to put it back in the holder and it's going to sit there for a few minutes. If you get into this habit of doing this, and especially at the end when you're done, you just shut it off and leave the solder ball on there, it will help protect your tip from everyday oxidization and things. I've had tips last 10 years before I need to replace them by using it, by taking care of them in this manner. So invest in really good, quality tips, quality workstation. It'll save you all kinds of grief building projects later on, and you'll get used to the way the tool feels. So that brings up the topic of feel. So when you're starting, you won't notice this when you're first learning how to solder, not necessarily, but there's a little bit of time where the solder doesn't flow. You're heating up the joint, okay, and you touch it with the solder, it's not ready. Then all of a sudden it starts to flow. There's a certain feel to that flow. And I can't convey that in a video, but we will attempt to mimic it today. So we got our board, and we're gonna bend some wire here. I'm just gonna take a guess. Okay, tools are on the wrong side. I'm not left-handed, I'm right. So we'll just bend a piece of wire and shove it in a hole for right now. All right, just like that. I'm going to bend it a little bit so it stays up. Okay. So the topic of the feel I was talking about, it's related to what's called thermal mass. So what that means is, it doesn't mean how much does the temperature weigh. What thermal mass stands for is how much heat is stored in a tip. So for example, I have different types of tips. So if I need to work on something, say, that has large wires on it. You gonna focus for me? There you go. I use a much larger, this is a 1/4 inch tip. This will store more heat than the 1/8 inch tip we just tinned. Consequently, this tip, which is very thin, conical, this is a conical one, has the least amount of thermal mass, ability to store heat, that of all the tips that I have. Okay, so it depends on what you're soldering. You want to choose the correct tip. So I buy different size tips depending upon what I need to do. I've got a knife style, a knife edge tip. It's hard to tell because I keep solder on it. And this camera is going to drive me nuts today. Okay, I have some really long tips. Okay, another chisel tip. It's another 1/8 inch, but it's really long. So it has a little further reach and a little more thermal mass, so it can store more heat. And that's all thermal mass is how much heat does it store, does a tip store. And you'll know when you don't have the correct one, if you don't have a tip with sufficient thermal mass, is because you'll notice the temperature. My Weller has a temperature display. It'll keep going down, and your solder's not melting, and what you end up doing is heating up much more of the board, excuse me, and the components around it, the traces and things. So you really, when you're soldering, you want to get in and get out. Okay, you don't want to be in a situation where you're sitting here waiting and waiting and waiting, all the while your temperature is dropping on your display and nothing's happening. So that's the sign that the tip you are using is not the right size for this work. And a lot of that comes from experience, knowing which tip to choose for your project. So, but there are some general guidelines. The 1/8 inch chisel tip is the one I recommend to use the most for most building, kit building, it works just fine. You don't need anything else. Now, when you're working on, say, some power supplies that have a lot of current, have much larger wires or connections, you want to use a larger soldering tip because that contains more thermal mass, it stores more heat, and it can deliver it quickly to the joint. And there are some techniques to help your tip along, and I'll show you. I will show you here. So back to the soldering examples. They are using a conical tip as well, very similar to what I have. Heat part and pad, which is correct. You start there. 2 to 3 seconds is about right. But here's how to tell when it's exactly right. Got some solder here. Of course, I was organized and I showed everybody everything, and it's not. There we go. Okay. So how to tell when it's ready. Got our wire down there. So they're coming in on the side like this and soldering. Now it's not ready. I'm on the, if you can tell, I'm on the opposite side of my iron. And then it just flows. Just like that. Now I'm soldering on the top of the board just for educational purposes only. Sometimes you have to solder on top of the board. That's one way to repair a through hole that's been pulled out on a double-sided board. You just solder the component on the top or the bottom. We'll do this again. Light pressure, solder on the opposite side of the iron, and it'll just start to flow, and then you're done. That's it. Now, there are different ways to hold your iron. Now, that depends on what you are soldering. If you want minimal heat, you use it on like a 45-degree angle, like that. If you need to transfer, if you want to transfer more heat quickly, you turn it vertical and touch the component. See how quickly that came up? Turn the other side. Okay. You use the skinny side, like so, the edge, or use, I want to call it the fat side, but the broad side. How's that? The chisel side, let's call it that. Okay. And that's the technique I use to control my temperature. So I have my Weller workstation all the way open. It's 856 degrees Fahrenheit. What I do is make another bender here. What I do is I use my time on the pad to determine when I should pull it away. Okay, so now I want to do this one a little faster. I'll use the side. Careful touch. Just keep feeding it in. There, done. Okay, so on the back side of this, now we've got some. You can see, so right here. Hold on, try to get you in the shot there. So we can see on this one, right here, that's the example of too much solder. Okay, that's this one. You know, I'm gonna switch to the microscope. Hold on, that'll be better to see under here, I think. going to stick with this. Still trying to figure out camera stuff here, guys. So we can see right here, this one, right there. Too much solder. Nice big blob. Nice big blob of solder right there. Too much. This one right next to it, right here, that one's too little. You see how it didn't flow all the way through? Okay, that's too little. On the other side, we see one that's of the correct shape. That's the graphic. That looks pretty good. This one also is not enough solder. Actually, I'm thinking that's a cold solder joint. I may have made one. So, so there. Let's do this. We're going to put it back, except we're going to put the lead in. We'll put a lead in. Turn that around for you this way. Okay, cool. See if I can create a cold solder joint. Okay. It still came out pretty good. I don't know if I can really create a true cold solder joint. Despite banging on it, it still came out pretty good. Another example of too much solder. See on this side, too much came through. So anyways, this is the way when you're learning how to solder, just buy some of these boards. These happen to be really high quality boards. I got them off Amazon, and the links on the web page for this episode. And I got like five high quality boards for $6. Great prototypes, things you can mess around with, practice soldering on, things like that. Okay, let's see the graphic again. Did I cover everything? We covered how to put your iron on the joint using the chisel side or using the edge to control the temperature of the joint. Leave your soldering station wide open. That's the way I prefer to do it. At maximum temperature, and just it's called dwell time, how much time you spend on the joint to control the heat. Okay, you're not thinking, well, my solder melts at 485 degrees Fahrenheit. That's I need to set it for 485 degrees Fahrenheit. Or, no, you don't. It needs to be a lot hotter because you have to heat up different components and their leads and the circuit board. So there's other parts of there are other parts need to be brought to temperature before you can solder. So there you go. Practice, just practice. That's the best way. That's the best way to learn, and you'll get you'll start to notice the feel of when the solder just starts to melt, and then you know you've got it you've held it at just the right amount of time. You push the solder in for a second or two, just enough to get a good joint. The one on the top here, this one. There. When it looks like that, you stop. Just pull it away. Don't blow on the joint, because that can cause it to become a cold solder joint. Cooled off too fast. You saw me thumping on it. I was trying to create a cold solder joint. So when the solder's cooling off, when you pull the iron away, it's still liquid. But as it cools off, it goes through these phases before it becomes solid. And if you're in, I think it's called a plastic phase, if it's in between a liquid and being a solid, and you bump it, that can cause cold solder joints to happen, or fractures in your joint, where things may work at first, but after a while, your project stops working, and you're wondering why. The graphic here left off one example, and you see this in older equipment where it shows too much heat. You'll see it as a dark gray. This joint will be a dark gray, but you'll find, you may need a magnifying glass for this, but you'll find it has a dark black ring that goes all the way around the joint. So that's a fractured solder joint. On the surface, when you're looking at it, it looks okay, but under magnification, you notice this. The joint's intermittent and can sometimes cause problems, and will cause problems with your projects. So how do you fix that? Well, next topic is fixing solder goofs. And I will show you. A couple of tools, as usual. You need solder sucker. This is my favorite one that I use. I've got a much larger one, depending on the project, of course, depending on how much solder you need to suck. Let's see, Chemtronics. And the other tool is solder wick. Okay. So a solder sucker does exactly what it sounds like. It sucks solder. It does this by pushing in a plunger, which has a tough, strong spring inside. When you heat the joint up and the solder is liquid, you just hit this button, and it'll pull the solder out of the joint. So for most double-sided boards, this type is fine. And I use this the most. There are times you have to do repairs where you can't use a solder sucker. You can't get it, maybe you can't get the tip in there, or what else. There's some reason. This is where solder wick comes into play. So solder wick has rosin already in it. It's impregnated with rosin. This will help wick the solder. So very clean copper braid with rosin on it, hit it with when you put the soldering iron on top of the joint, then it'll pull the solder out. So this is what we will do. We will test it right now. We're going to remove some solder. So first we'll use the solder sucker, and we'll use this one here because it has a lot of solder on the joint. Okay, so you clean off your tip just like you normally do. Put it on the joint. You'll notice it'll start to reflow, and then you hit it and the solder's removed. That's it. Now this is a through-hole board. It's plated through holes, which means there's a little metal tube that's inserted through the hole to the other side of the board. So there will be some solder left inside that joint. You might have to do it again. To get it all out. Okay? That's how a solder sucker works. But sometimes you can't use a solder sucker. You have to use solder braid. Now solder braid, we already talked about it, also comes in different sizes. And here's one size for fine stuff and one for not so fine stuff. It's not real expensive, keeps them on hand. And solder braid works just like this. So we'll go to the next joint right here. We'll work on this one. You just put some on there, touch it to the joint, and you'll see it's lifting the solder out of the joint. A little awkward here on this angle for the camera and my you can see on the back, it started to wicking up the solder. That's the solder wick. Now, a lot of times I see when you're using solder wick, you have to be careful. It is rough. It has a rough feel. It has rough edges on it. But what I see a lot of people do, and you absolutely don't want to do this on your boards, is when you're using the technique for solder wick is you want to put it on the joint, heat it up, move down a little bit, heat it up, move down a little bit, and heat it up, okay? You can squish it and things like that, it don't matter. What I see people doing on a lot of YouTube videos is this. They rub it back and forth. Well, or they'll leave the soldering iron flat on the part and they pull it like this. Okay, so that's going to ruin your board. As you can tell, it already started taking off plating and scratching the printed circuit board. Did I take that plate off? Things like that. You don't do that. Don't grind it back and forth like this. Okay? Just put it on the joint, like so, and lift and move. Okay? Lift and move. All right? So let's see. So we covered up how to fix goofs and things. Let me see if I can do a solder bridge. So you remember at the beginning of the episode I talked about using side cutters versus diagonal cutters instead of the. So if you look here, you see how that end of the wire got mushroomed out? Imagine this on the other side of your board and you need to remove the component. This is where if you pull too hard, it could pull the through plating, that little metal tube, out of the circuit board. Now, on a double-sided circuit board, like I said before, it's not such a big deal. You know, you can solder top and bottom of the component and everything's fine. If you happen to be repairing a multi-layer board or working on something like that, you're probably got a dead project. So always use the side cutters that I showed you before. These are Plato's Model 170 shears, because they create a cut like this. Okay. So let's create a solder bridge. Let's see if I can do that. Let me trim off that mushroom piece because it's not going to fit through the board. All right, we're going to do it this way. Flip it over, and we will create a bridge solder joint, and I'll show you how to fix it. Clean off the iron on the sponge. I didn't talk about that, did I? So, it's going to take a lot of solder to bridge this. It's just falling through the bottom. The other thing about, I use a sponge, and I keep my sponge, I wet the sponge only with distilled water. I don't let, where I live, we have a lot of we have very hard water, and I don't want those, I don't want the, whatever makes water hard, I'm not a hydrologist or anything, to ruin my tips. So let's see if I can do this. I can't even create a bridge solder joint. Okay, so we will pretend it is. I'm sure there's all kinds of solder involved. Oh yeah, definitely too much solder. We will go over how to repair it anyways. This is where solder wick comes in handy. Okay. If there was a bridge between the joints here, you just lay solder wick right in the middle of it. Give it a couple seconds. You can see how it drew all that solder out. Like that. And that's how you would remove a bridge. And it happens. It happens to all of us. If someone tells you, I never created a solder bridge or never created a cold solder joint or not enough solder, they're lying. It's plain and simple. Because we've all done it before. All right, so that brings us to, we've done the solder goofs. You saw what I was using was called, to hold the board, was called a pan of ice. We use those forever as well. I found another circuit board holder that I really like. I got it at the Yuma Hamfest a couple years ago. And this one it's like a vise. So it's adjustable. So you can hold tiny boards with it. Or pretty wide boards. I can't even show you. I'd say probably about 10 inches, 10-inch wide boards, to about, I don't know, I would say 10-inch by 6-inch on this. What I like about it is not only does it hold it on the edges, it rotates. So you can put parts on one side, put this, have the silk screen side up, inserting parts, and then when you're ready to solder, you can flip it over, solder all the parts, and it makes it kind of nice. I think this is like $15 on Amazon. I think I found one on Amazon as well. So, okay, I gotta get a little cleaned up here for a moment. Yeah, we'll use this one. Get organized here, because we are going to start building the kit. So if you've followed along on the website, this is the kit we're building. It's a general purpose amplifier kit. What it'll do is it'll take headphone level audio, like out of a scanner or something, and make it so it can be played in a room with a speaker. I chose it because it has a good wide range of different types of parts in it, all through hull for this project, and we can go through and we'll talk about all the different parts, what they look like on a schematic, and we will build the board. So let's get going. What I like to do is I start with the manual. I like to go through it first before opening the parts. 9-volt battery, a little speaker, and just familiarize myself with the project. I've not built one of these before, so here's the full parts list. I look at the parts list. Idea of what kind of we have capacitors, we have an amplifier integrated circuit, some potentiometer, which is a variable resistor that's used for varying resistance to a variable resistor. That's going to be the volume control. We have a transistor, a couple resistors, speaker, 9-volt snap-in, battery, lead, PC board. Sometimes you hear it called printed wired board, PWB, but that might be some other countries. And we have the speaker, of course. So it's going to be upside down for a little bit. I'm not sure how I don't remember how to flip it around. Let's do that. Let's see, video capture device. I thought there was a way to flip it around. I can't remember. All right, well, I'm not sure on this one. Okay, so I'll just read it upside down. So they give us some of what the components look like for the project. They're giving us resistor color code chart. Here's the NPN and PNP transistors. And that's what they look like. 3-leaded device. And how to remember, one of the ways I learned it in school, between NPN and PNP is NPN stands for not pointing in. So the little arrow here on the, shouldn't use my fat thumb for this, the little arrow on the emitter points out. So that's an NPN pointing in pointer. It's a PNP. Okay. They all have base emitters and collectors. These are standard transistors, standard resistors. They have an IC socket to use for our integrated circuit. And this is a standard LM386 amplifier chip. Let's see what else. What's inside? Oh, it's just 2 pages. Okay. So this project gives us, if I was really smart, I would have opened this up earlier and created a PDF out of it and put it on the screen. Gives you an idea of all the parts that you need. I'm sorry, all the tools you need. Gives us assembly instructions. Gives you an idea of how the circuit works, theory of operation, and that's important when troubleshooting. Give you a schematic, and we'll go through the schematic a little and show you how the signal flows through the schematic. And they give you a layout of the solder side of the circuit board. And they give you some troubleshooting tips. Okay. Common things that can go wrong. Now, these troubleshooting tips that are in here, they don't just apply to this project. These are common things you can do across many kit building projects, or doing a project out of a magazine. We'll do that one. We'll find something as well in a magazine, and we'll start. I'll do an episode on that, so you can start with a project that has no instructions, maybe minimal instructions, and maybe learn how to order parts from the various vendors. And actually build it. So we can thank Assembler 9 for putting our kit together for us. So the next step after you've been through the instructions or manual is to open up your parts and inventory them. You want to make sure you have all your parts. So they give us wire for the speaker, be my guess. Okay. So we know we have a volume control. This is what a potentiometer looks like. It's a 3-leaded device. So this component is a 50 kilo ohm potentiometer, and you can read that value at the top right here. 50. Put it down closer to the ground. There we are. We'll use the microscope. How's that? So, okay, you're right side up. The other main camera's upside down. So it says 50K. Right there. Most potentiometers are marked that way, in this fashion. They have a label on it like this. They're labeled, or on the back, it'll be stamped in the metal. It'll tell you what kind it is. Now, there are 2 kinds of potentiometers. You'll find them. They're called And we do. Okay, so now we know we have two of these, C1 and C3. Now what I do with parts is I keep like parts together. Okay, so capacitors go together. We'll look at our next capacitor, which is a 4.7. No, we have two disc capacitors. So these are discs, obviously, but by the way they're shaped. Okay, they're shaped like a disc. And they are stamped 0.01. So typically all disc capacitors are stamped. They'll have different markings on them. For example, they might have 103 or 104. So you take the first two digits, 10. So for example, if you have a 104, it'd be one. Oops, I don't know if I can do this. So you have a 10. Okay, hold on. Let me get a pad of paper, write this out. My brain is just not going to do that. So I'll have, say, for example, it has a marking of 104 on it. It'll be a 10 followed by 4 zeros. Okay? Like that. Picofarads. Or puff. Some people call it puff. Picofarads. So if you want to know what microfarads, it's typically capacitors are done in microfarads, farad, or picofarad. On occasion you see nanofarad. That's in between. So if we have a 10,000 picofarad capacitor, I keep a little cheat sheet from a long-closed company called Gateway Electronics here in San Diego. I'm just not bouncing numbers around in my head. So we go down the picofarad scale. It's going to be 10,000, which equates to 10. Oops, sorry, did I cross that? Yeah. Yes, 10 nanofarads or 0.01 microfarads. Okay, that's it. You'll see 103. So 103, I did 104, right? So 10, sorry, I chose the wrong one. 10 and 4 zeros is 100 nanofarads or 0.1 microfarad. You'll see that a lot on disc capacitors. So keep something like this handy. You can make it yourself. I'm sure there's other cheat sheets available on the internet. Just look around. I also keep one around for resistor color codes. When you start building a lot of kits and things, you will start to memorize what these values girls, but violet generally wins. Now, if you're in the military, have been through electronics school in the military, you've probably found this video incredibly boring. But there are other mnemonics that are not safe for family TV. So, big boys race our young girls, but violet generally wins. And you can remember the order. Okay. There's mounting hardware for our variable resistor. We'll put on. All right, what's next? We got the two disc capacitors. We will put those up here with the other capacitors. Check those off. We have a 4.7 microfarad. 4.7 microfarad, 200 volt Nichicon. Nichicon is one of the better made ones. So the other thing I didn't mention on the other two electrolytic capacitors is electrolytic capacitors are polarized. So this points to the negative side. Okay, very important to remember this. If you put an electrolytic capacitor in backwards in a circuit, depending on the voltage, it will just explode. I had a lot of fun in my high school electronics class, so that's how I know. Disc capacitors are non-polarized. You don't have any polarization to them, but there is a way you should put them in the circuit so that way you can troubleshoot it easier on your board. So we got that one. C5, another one. Okay, so two formats on electrolytic capacitors. This one is called an axial lead because it goes straight through the axis, okay, straight through. Leads are on both sides. Then you have what's called radial, where the leads come out of one side. Now the negative arrow, the negative lead is always marked. And this has come from a tape. It was cut off a piece of a reel of parts. And the negative lead you can see is shorter than the positive. So that way, if it's not marked with a band, you can use the shorter lead and be assured that that's the negative side. I've never seen it flipped around. But now that I've said that, someone's going to email me and say, hey, I found one that was backwards and it exploded. So sorry. Okay, so let's keep the capacitors together. Check that off. Our integrated circuit. Standard LM386 chip. Okay, so integrated circuits have pin numbers, and all integrated circuits that I have seen have this semicircle at the top, okay? And that's what the semicircle designates, is the top of, this is the top of the IC, so pin 1 is always to the left. 1, 2, 3, 4. Now which way does the counting go on the other side? 5, 6, 7, 8. It wraps around the chip. Okay. Then they typically have the part numbers. So this one's a LM386N. Now, if you don't have a data sheet on this, you can put that part number in Google, say data sheet LM386N, and you can get every bit of information about that integrated circuit. And it's handy to keep. It'll help you understand how it functions, how it's made, and I find data sheets interesting to read in general, so they're just fun for me. Okay, so we got the integrated circuit. Now the thing about integrated circuits also is they can be very static sensitive. Talked about earlier in the episode about electrostatic safety, ESD workstation, electrostatic discharge, all that stuff. They are very They can be very sensitive, and it'll say on the bag when they come from a vendor like DigiKey, they'll say on the bag, in fact, I got some around here, they'll say on the bag, they'll have something like this, okay? They'll come in a bag like this. Now, just about all electronics come in bags nowadays like this. Some will have double warnings or triple warnings to be very careful. And you should pay attention to that. So that way you don't accidentally fry a expensive integrated circuit. Okay, so we got the IC. What else we have? Q1 2N3904 transistor. We spoke about transistors on the schematic. And here you go. I recommend you get one of these little cameras. This little microscope camera I'm using is a $20 digital microscope. I'm at the age where my eyes are changing for some reason. I have no idea why. Reading small print and things is becoming more challenging. So I bought this little scope thingy, and that's what I do. I have it up on my bench computer running, and if I'm having a difficult time reading part numbers, I just stick it under there and look at it on the screen. So that's our transistor, and it's also from a tape reel. So if you can imagine more transistors stuck together on one piece of cardboard, this was cut off tape and reel. Okay, that's the one of the formats. The other formats are bulk, where they're just all thrown together. Tape and reel. There's trays. I try to remember the rest of them, but most of the time on kits you just get this level. You get them like this. So we can scratch that off. Resistor 1, 33K. Okay, so this project only has 2 resistors, and even without knowing color codes, you can tell this is the 33K. Logic dictates if we only have 2 resistors, one of them being 33, having the 2 same numbers, the first 2 stripes will be the same. So by process of elimination, you can say this is 33K. But also looking at the resistor color code, you have one handy already. Big boys race our, this is orange. This is a 3. First digit 3, second digit 3, 3 zeros. So 33,000, yes, 33,000 ohms, or 33K. The gold band stands for 5% tolerance. Okay. There are other bands there as well. There's also a 5th band. There can be ones with 5 bands, and that's usually, oh, I'm sorry, gold is 10%. Silver's 5%. I got that backwards. I'm sorry. There are other colors as well. Yellow is 4%. 3% is orange. Red is 2%. And a brown is a 1%. Now, this is where things can really get confusing, because molded inductors look just like a resistor. They have their own color codes that can appear like resistor color codes. You have to pay attention and make sure you don't mix the two up, because your project definitely will not work if you mix up a resistor with a molded inductor. Okay, this project doesn't have it, but other projects might. So that's something you need to pay attention to. And the other reason why I keep my parts organized together, capacitors together, resistors together. Okay, discrete components, integrated circuits, and things together, then this is a IC socket. Now, I guess they want you to use one because it is easy to apply too much heat to an integrated circuit and ruin it, especially for beginners. So this gets into the circuit instead. This goes into the circuit. This gets soldered into the circuit board. Get a better focus on that. The leads go down. Go through the circuit board. It gets soldered down, and then the IC gets plugged into it, like so. Okay. This one is going to have a nice fit. Okay, but not all integrated circuits will fit easily, and I will show you a technique. If they're flared out too much, if the legs are flared out too much, and say they're doing this, no, they're not. They can't quite get in there. I'll show you how to fix that so they go in nicely. Let's see, we got that. We got our resistors. I showed the speakers, 9-volt snap-in, 8-pin socket. Okay, PC board wire. Okay, so we have all the parts. And we are ready to start soldering. Are we? Not really, not yet. We need to look at our circuit board. So this is a single-sided board, okay? Pretty standard in the kit world. Sometimes you'll have double. This one it's not tinned, okay? So tinned circuit boards will have what looks like solder on them. Well, it's not solder necessarily, but it'll have a silver look to it. I don't think I have any tinned. I do have a tinned board. I'll show you. Okay, on the amplifier project, the Tetra boards. So this is what a tinned circuit board. You see the circuit, the traces are all silver. Yeah, so this is tinned, and this makes for good soldering, and it protects the traces, the copper traces, from oxidation. Okay. This board does not have that. So, and it doesn't need to be necessary. For this little kit, I don't know, it was like $12. They're not going to go through the expense of tin plating the traces like that. Okay. No silk screen either. So, we have to pay attention to the board layout to know where the parts go, how they are oriented, etc. Some of the more expensive kits will have silk screening on here, and it'll make it easier to populate the board. But first, before we get started, as you can see in the microscope, it's not real shiny, is it? Looks kind of dull. And it is. So what we want to do is we want to wash it. We want to clean it. We want to take a little bit of, I use dish soap and a little, green Brillo pad, and clean off the board. You want to get you don't want to have any oils on your board. A little dab will do ya. Or any other gunk. You want to, when you're cleaning off the board, getting the gunkies off it, don't scrub real hard like you're trying to scrub a pot or a pan in the, baked on lasagna in your kitchen sink. Just a light scrubbing is fine. You want to get off any other oxidation and stuff like that. and then just dry it off with a paper towel or tin. And don't touch the board with your fingers yet. Okay, you don't. When you start building, you want to keep your fingers off the traces and just hold it by the side. So that looks a little better. Got some shine on it. You can kind of see the shine now. A little better. Okay, so now that this has been done, make sure there's no leftover paper towel stuck to the board. Boy, it looks a lot better in person than it does on the camera. There isn't little bits of paper towel stuck in a hole or on the edge of the board. Now we want to clean it with alcohol. That 100% stuff I showed you earlier, that's what this is used for. So you want to clean. This is a small board, you can clean both sides, I guess. Just don't put your fingers on it. Don't touch anything. Just wipe off any excess. It's going to dry. You'll see it evaporate pretty fast here. Okay, see, it don't look on. But you see how much shinier that came out? Okay, so it took all the stuff, all the oxidation off it, and this is going to make it a lot easier to solder, but don't touch it with your fingers. Only hold it by the edge of the board. Okay, so now we're about ready to start building this thing. Let's bring up our PCB holder. I wonder if I can, hold on a second. Let's see if I can do, so I'm going to take a picture of this. Picture of it. I'm going to take a picture of it and put it on the screen. All right, I'll do it this way. I'm just going to use let's see, now I want to add an image. Hold on, almost there. There we go. Hold on, I'm just trying to get the order changed here. There we go. I don't need to see all of it, but I'll leave it on the screen. Okay, then I can get this out of the way. All right. Now I can keep this aside for myself. My brain is not functioning backwards today. So again, hold the board by the edges. So looking at the way the board is laid out, we're going to call this the top of the board. This is the top of the board. Okay? Because you can see up on the left where the speaker, I'm sorry, up on the right, there's a speaker. The speaker leads are right here. And we'll call that, we will call this the top, even though it's the output. Okay, so we mount it in our nifty holder here. And we'll start populating a board. And that's what it's called. Or stuffing a board is another term used. Populating is another. Now remember, when you're working on this board, when you flip it over like this is the top. Okay, don't keep that in mind while we do this. Okay, so now that we have all our parts sorted, I'm going to move them out of the way from up there. Which ones do we start with? So I use a technique I like to call stacked building. Stacked building and right reading. So when you put a part on the board, you start with the components that are closest to the board first. Okay? And then with the component markings, you want them installed on the board so they read left to right. So for example, our 33K resistor we had earlier, you'd see wherever it mounts on this board, right here actually, it would read orange, 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 gold. Because this is the top of the board, this is the left side of the board, we read left to right. So we want to do it in that fashion. When you're mounting IC socket, or IC, integrated circuits down, that may not be the case. You have to pay attention to that. Pay attention to where pin 1 goes. It may not always be on this side, it could be over here. So your labeling will be upside down. Same with electrolytic capacitors. Because of the circuit design, they may have to be upside down. So there are certain caveats to that rule. But in general, I've found that to be the easiest way to build even the most complex projects. I have an N2PK network VNA, all surface mount, that it's taken the last 7 years to build, that's ready for testing, and we'll work on that as another episode. And that was all built surface mount, right reading as much as possible, and stacked building, so it made it a lot easier to assemble. Okay, so I like to start with resistors. Move those over here. So looking at the chart, at the parts layout, we can identify where Q1 goes. Okay, we know Q1 goes right here, just by the layout of the transistors. That's the center of the board. Here's our integrated circuit. So looking at the parts layout, you want to familiarize yourself with the layout itself. Here's the capacitor C6, C4 is that long one, battery terminals, C3, The signal in is here, and ground is here. And you've got another capacitor, C1. Now you notice in the parts layout, the positive side's down here, where the positive side on C3 is up here. Okay, so be careful with that one. It looks like the integrated circuit pin 1's here. We got another capacitor C6, another capacitor C5. Potentiometer gets wired in right here. Speaker goes out there. So okay, we have a fair idea of how the parts are laid out. And we'll get started. So, bringing my favorite toy out, put it on the board, we'll get them at, we'll figure we are doing R1 first, which is, going to the parts list, R1 is our favorite 33K. So that goes right here. I like to start with resistors and work my way top to bottom, right to left. I think I may have misspoke about the direction of the resistors. It should have been, yeah, left to right. Never mind. Put it in the, bend the leads down nicely. Okay. And this is why I like that little tool. Underneath the board, what you can't really see is I splay the leads out a little bit. So when you turn it over, everything doesn't fall out. Now check off. So I used an X to determine the parts were there, and then I use a check mark when they're installed. So R2 is the 10K, which is the only other one we have left. That's black, brown, orange. I'm sorry, brown, black, orange. I got that backwards. Goes up here. Again, right reading, you can see the numbers, or the bands, brown, black, orange, and the tolerance left to right. Let's see what else we got. C2. Okay, so now we're going to start working on capacitors. So we have C4, which is the 4.7. I think it's this one. And it is 4.7. Now we're working our way across the board, left to right, top to bottom. Put center of the capacitor in the leads here. Okay. Make the bends. I have to take it out of the shot here. All right. Remember the polarity we talked about? So looking at the parts layout, this is the negative side. So this arrow, okay, this arrow should point down. Now, another technique for loading parts, when you're bending leads and things, I like to place it so the component values are on top so you can see them. Having it where the component values are on the other side where you can't see them, it makes it more difficult to troubleshoot. So when you're installing your parts, yeah, keep them up, keep the values visible. It'll save you a lot of heartache when you need to troubleshoot it. So the next one is C3, working our way left to right. C3 is our 1 microfarad electrolytic. And that's what we got. That's what we'll use. And it goes from here to here. Now, looking at the parts layout, you'll see the arrows pointing down, so that tells us the negative band, the negative is right there. Take my favorite little tool. So run into a bit of a conundrum here. Can't get it in there. It's too big. All right. So we need to use our needle nose pliers. Do we use these with the ridges to bend our leads? No. Remember, it can damage the lead of the component. We use this smooth, and we make our bends. I made that at the wrong spot because we want our component value to be upright. So we'll bend this back. Got all excited there. Bend it as close to the body as we can. Form the leads. Like that. Just push them in. We got our value on top. Now, what happened to the band? Where did the negatives go? Just, this is where taking your time. Oh. Okay. I didn't pay close attention when we first looked at these. So, there are another type of electrolytic capacitors that are what's called non-polarized. That's what the NP stands for in this particular brand. What that means is it doesn't matter how they're installed in their circuits. Okay? This is common in audio circuits. Why they didn't mark it out in the instructions, the parts layout clearly shows a positive lead and negative arrows and so forth, but this electrolytic does not have that. So how do they make non-polarized electrolytics? Because there's two of them in there, essentially. So for example, imagine there's halfway through, here's the positive lead, inside would be the negative lead of 1, okay? On the other half is the other one. You got positive, negative. This, for the second capacitor, on the other half, it's positive out here, and the two negatives are put together. That's just an example. It could be negatives on the outside, out on the leads, and the positives tied together. So that's how they create a non-polarized capacitor. So for us, it doesn't matter on this kit, but we will still install it right reading so the capacitors read correctly. One goes there. One goes here. Same with the other one. Same with C1. C1, C3. Doesn't matter. Put it in. All right, I think we got enough parts. We need to time to solder. Flip things over. Time to solder. And I'm going to change my mind. I'm going to use the fatter solder on this project instead of the thinner. Tip cleaned off. It's all ready to go. Again, solder methodically left to right. Just like that. Let me get the focus a little better for you. Okay. I see I'm using the fat chisel part on the pad. That's because the pads are kind of large. So I want to have a greater surface area to transfer the heat. And I can already tell I'm going to run out of time today. We won't get to testing this, but we'll get it built. I've got my in-laws coming in today. Later today. All right. Put a little solder on the tip. Double check everything. Looks like one of the resistors lifted a little bit, but that don't matter. So then we go through with the trimmers. I see I'm lagging again for some reason, but I'll keep going. Carefully trim off all the leads. Don't let the leads fly around your bench. Grab them. Sometimes you can put your finger over them. You don't want pieces of metal flying around your bench. Okay, so that part's done. Okay, so what's next? So now we work our way up again. All the capacitors except C5 are in, so I forgot that one. So C5, this one also has the band on it, so it's polarized. Cut it off the tape, and then it goes positive. The band goes up like that. Okay. Quickly flip it over and solder that one down. Tip's clean. Fat side of the chisel. Feed the solder in on the opposite side. Pull it away. Okay, flip it back up. All right, what's next? The two disc capacitors, C6 and C7, it doesn't matter. I'm sorry, C6 and C2. So these have the markings on the front. When inserting them, for ones that are vertically oriented, I insert all the markings to the left. And if they're horizontally inserted like C2 is, I have that facing the bottom of the board. Okay. Let's see, so that's that. Okay. Double check, be methodical, take your time. Solder the remaining part. Solder left to right, top to bottom. Okay. Ooh, left a hole there. Okay. Don't blow on your solder joints. That did not, I didn't put enough solder on that one. See, I told you. If anybody tells you they don't make soldering mistakes, they're lying. Don't let your cutoffs fly around. And I've got another one with not enough solder right there. Two, actually. Part of it has to do with the angle of the board, so it stays in the camera and I'm not fully seeing it. Okay. Give it a second. All right. That's in. So now we're just down to the IC socket, which I have here, and the transistor. So we have to pay attention to the orientation of the IC socket. Remember that notch right here? According to the parts layout, it faces left. So we drop this in. And underneath the board, I'll just reach under and bend a couple of leads over so it stays in place. Okay. And then we have our transistor. Now we got to figure out, well, it's orientated on its flat side. The flat side faces towards the bottom of the board, so that makes it easy for us to see which is the emitter base collector. When you're assembling, you don't have to worry about that so much. Just pay attention to where the flat side of the transistor is, and then just bend the lead, the center lead. This one goes down, just out a little bit. Give it a little chicane right there. Like that, man. Hopefully this will just kind of drop in. It might be a little snug, and that's okay. Just like that. All right. We are going to flip this over. Okay, we're missing something else. Oh, it's two signal inputs. Interesting. All right. Now this is where I need the thinner solder because the transistor pads are small. That's why I keep different size solders around. Now this technique will be more on the chisel tip itself. We don't need that much thermal mass to solder these down. The pads are small, the leads are small. Okay. Now what I like to do, because the IC socket will be kind of loose. I'm getting laggy again. What I do is I solder one pad down, and then from underside the board, hold on to it and let it cool. Then you can solder the rest of the components. Okay. Solder the rest of the leads, I meant. Opposite side of the iron. See the iron tips getting black. That's from the rosin. Wipe it off on the sponge. enough solder. Now, integrated circuits is a good can get solder bridges. That's one place to watch for. Watch for solder bridges. So all the components are loaded. All that's left was now testing it and so forth, which I unfortunately have run out of time for today. But there you have it. There's your first kit. We'll mount the IC in there. Now mounting the IC, this one goes in nicely. If your leads overhang, what you do is on a flat surface, okay, on one side of the IC, it's kind of hard to tell when my finger's in the way. You slightly bend the leads evenly on the desk, and then it'll go right in. So the semicircle is facing left to match the integrated circuit. You set it in there and you carefully push it in. And there you have it. Your first kit's all done, ready for testing. So I hope you enjoyed it. SMARC, K6WKE here, sunny Southern California. There will not be a live stream on the first Saturday of January, which I think is the 4th or 5th. I don't have a calendar here. Everybody's going to be with their families and things. I will be too. And wish everyone Merry Christmas, Happy Holidays, Happy New Year. And we'll be melting solder again in about a month. 7-3. Talk to you later.